I'm Martin. I teach in Suffolk, for those of you that don't know. I do mark for the OCR exam board when obviously the exams are up and running, and I just put these on because I saw that some people were saying that they'd find them useful to go through. Today we're just going to have a look at a little bit in terms of teaching algorithms and looking at some of the key points and things that I think are useful when you are teaching algorithms, and just kind of share some of my ideas. And if you've got any of your own that you think are useful, then by all means feel free to share those ideas. If you do have any questions or anything as you go through, please feel free to kind of unmute yourself if you're muted, and ask away. Feel free to interrupt me. If it does let you use the chat, for some people it may do if you've been on one of my meetings before, then by all means just put a question there as well, if you prefer to do it that way. So we've been looking at 2.1, which obviously has got a number of different sections. The previous two meetings have looked at the computational thinking section, as well as the standard searching and sorting algorithms. Those are available as videos to watch, and they're on YouTube if you haven't seen them already. And I will share a link afterwards so you can hopefully find all of them. But what I was looking to do today really is to focus on that, producing algorithms and looking at interpreting and completing algorithms, and how you can go about doing that, and just ways that I do it. Obviously, there will be a slight change with this later on in terms of the use of pseudocode and so on when you get to J277, but it shouldn't be too different. Pseudocode will still be valid, and students will still be able to write in pseudocode, but there's obviously the OCR reference language on top of that they're going to use, and the purpose of that isn't really to throw anyone. It's just that their standard way of writing algorithms in the exams, and they want to have some kind of structure that all students can follow, and so that's all really the OCR reference language is. You can kind of think about it as another high-level language, but if they choose to use things like Python or whatever language you use, then that's fine as well. So we'll just go into that in a little bit more detail. So kind of when it comes to writing algorithms, writing in a chosen language is completely fine. Whatever happens, even next year, unless it says specifically to write in a certain way, students won't be marked down for writing in whatever their chosen language is, and see that's most likely going to be whatever language that you teach them. We teach in Python, as I know a lot of schools do, purely because the syntax of it is really easy to follow, and then it helps with teaching things like using indents and those sorts of things as well. But writing in Python is completely okay. If I'm getting them to write for exams, though, I tend to get them to make it a little bit more pseudocode-like. So we'll do a lot of coding in Python, but on top of that, we'll look at then writing for exams. And when it comes to those kind of exam algorithms, I'll then kind of get them to tweak it a little bit, just so that the keywords and things really stand out, and it's easy for the examiner to follow, and then there's less likelihood of any kind of syntax type errors creeping in if they've got this kind of structure that people are used to seeing. So I've obviously got some examples on the screen that hopefully you can see. So just turning all the commands into capital letters and just helps us stand it out. If they have to come up with something else, so for example they need a function for maximum, then writing in just a keyword like max in capital letters would be enough for the examiner to understand. And I think that's where the advantage of them writing their algorithms in more of a pseudocode type way is more useful, because they don't have to memorize every single function name that they're ever going to need, as long as what they're writing is clear and can be followed by whoever's reading it. So obviously max is quite clearly that they're looking for the max value in a list, for example. Then they'll get the marks for it. And so these are the kinds of things that I go through with my students as they go into year 11 and starting to do more work on kind of exam algorithms. But from the beginning, a lot of it we don't really teach the pseudocode type structure that early on. A lot of it to begin with is just looking at teaching programming, and for that one we just use Python a lot for that. So some of you that have seen some of my posts and things will have heard about me talking about Prim, and Prim is a really useful way to teach programming. It's no different really to how I always used to teach before I came across Prim and started to develop my own way of doing it. But what it does add to how I used to do it is a clear structure that students have to follow, and that structure tends to help people to understand what is going on a little easier, I find. So Prim is just an acronym, if you like, for a set way of learning to program. So to begin with, students need to be given a section of code, and then you just ask them to predict what they think it's going to do. This comes in two ways. So they should start really by tracing through the code line by line. So just read each line of code, think about what each line of code does mean. And then they should be able to come up with an overall purpose afterwards. So the predictions shouldn't be anything really basic. It should be them having a think about it in as much detail as they possibly can, using previous knowledge, or even just using kind of logical reasoning, if you like, to kind of work out what they're going to do. Once they've had a go at doing the predict, then they're allowed to move on and have a look at the run section. For this one, it's a case of just running the code, and they'll be able to see whether they were right or not, and how close they were, and that sort of thing. I take it a little bit step further than some resources will. So if you ever do some research on Prim by Jane Waite and Sue Sentence, they will have resources where the code is given to them as a file and they just click run to run it. I tend to find that it's quite a good opportunity to get them into the habit of writing the code, and so even just by sitting there and copying the code out, they're then getting used to typing in the syntax and making those mistakes that they'll hopefully then learn from. So I tend to add that part in there as well. So I give it the code as a screenshot that they have to then copy out before they're allowed to run it. Investigate is kind of your main way of getting them to understand the key bits that you want them to get out of that particular activity. So a series of questions that they can then answer that you kind of tailor towards it, and it can be anything at all. Any kind of way of getting them to think about things in a deeper way, get kind of improve their understanding. It could be to do with specific parts and how it works. It could be to do with just how things look, so they're getting used to what things look like. So right at the very beginning, I'll be putting questions in there like, what color does a print function go, and things like that, just so they're starting to notice those things like color coding and those sorts of things in there as well. And I tend to aim for 4 or 5 questions within the investigate, if possible. Sometimes a few more, sometimes there might only be 1 or 2 though, and just getting them to think there. Modify is really useful for looking at how well they understand what's going on in the code. So you give them a task just to change it, and it could be that you just want them to change the purpose of the code. It could be that you want them to have a look at maybe fixing the code in some way. And then the final part is then to make a new one. So look at using the same techniques, have a go at creating a new program. And I tend to try not to have it too different from the previous part. So the in the program I gave them, just so they've got something to work on, especially for the lower ability students. But obviously at the same time, it kind of needs to um, test them and make sure they have kind of understood what's going on. And kind of all those 5 stages are really important. But see where Prim really helps is if I just go back to this slide. Obviously, they need to be able to look at producing the algorithms, interpret the algorithms, correct them or complete them. And so if you think about how this ties in with Prim, so the predict part is looking at the interpret section of the specification. And obviously the run can go in with that as well, so they can see whether they're right or not. The investigate side of things will also help them with that interpretation as well. And then you've got the correction. Obviously, that can be the modify, or and the completion can also be linked in with a modify as well. And then the producing their own algorithms. Obviously, that it ties in with the make. So you can really easily cover all of those bases just by using this Prim method, and the students are meeting all of those things they need to have studied in the specification. And this is kind of an example of how I would set it up. So this has took me probably about 3 years to get it to a stage where I'm happy with. And this is an example of what we do. So this is the very first task I gave my year 9, because we start our GCSE in year 9. So the very first one that I give the year 9 students. So I give them a space to write their prediction. Obviously, there's a screenshot of the code as I was talking about. And then the next bit is obviously the investigate. And so as you can see, I've looked at getting them to think about the style of the code, what does it look like, and I've even got them to start to think about what happens if the brackets are missing or the speech marks are missing, so they can have a go at taking the brackets out or taking the speech marks out, and they can then see what happens as a result of it. So I can really start to kind of zoom in on what I really want them to start to get from it. And there's an expectation that those questions are answered in as much detail as possible. The modify section, obviously, I've just given them a little bit of a change to do. So in this case, I've just put their name instead of the words I'm learning to code using Python. And I get them to do a screenshot. So we do all of this on OneNote, and then that just kind of helps me to see that they have actually managed to do it. And that's more of an admin thing for me, so that I can just check that the work quite quickly. I can have a look through and I can see whether they've got it right and wrong without having to trawl through all their folders and files and look for the work. And then likewise for the make, obviously, because this was one of the first lessons, the make isn't that different from the modify. Most of them will just modify their previous one to then have a go at doing the next bit. But what will precede this is I'll have maybe 5 minutes or so at the start of the lesson, just talking through and introducing the functions that we're going to be looking at within that particular lesson. So in this case, I started with talking about the print statement and what it does. I think I also started to talk about data types, so they started to understand about things like strings and integers and those sorts of things as well. But then there'll be other things that I won't necessarily teach them, and I'll make sure that they kind of find those out for themselves as we go through. So what I thought it would be quite good for you to see is kind of how this actually works in practice. So on the invite that I put onto Facebook, I did mention about make sure that you've got some version of Python that you can use to go through. And I thought we could have a little bit of a go at running through a couple of prim activities, just so you can see exactly how it does work, and hopefully so you can see that there is some credit behind it. So the first one that I've got, hopefully everyone can see this screen okay. So if you want to just have a think about it or make a note of it, and just have a go at thinking about what your prediction for this code is. I'll give you a minute or two just to have a look through.
Oh, sorry. How do you move that?
So just from looking at that, can anyone predict what they think it might do? Anyone brave enough?
Yeah. Oh, that one's got me a bit. Okay. Do you want me to?
Yeah, go for it. Feel free.
Can you hear me? Am I unmuted?
No, I can hear you.
Oh, right, okay. I thought I muted it. Okay. So print 2 plus 2 is will print 4.
Yep.
Print quotes 4 times 4 will print 4 times 4.
Yep.
And 10 mod 3 will print 1.
Yep.
But I was a bit confused by the 10 mod 3. Oh, I see. Yeah, you've done text. So it will, the number 3 will print 10 mod 3, then 1.
Yeah. So obviously there's your prediction initially, and so that the students will obviously have that one. So in this case, especially the mod sign, I didn't teach them that beforehand. I was a little bit mean, just so I knew they'd get something, or I thought they'd get something wrong anyway. Some of them were clever enough to have already seen something like that before, but a lot of them, there was something that they'd get wrong initially.
Yeah.
So then the next bit is where you can then copy the code into Python, and then you can run your Python code to see whether you were right or not.
Sorry, can I ask a question?
Of course you
can. So the line 3, it says print quotation mark percentage sign 3.
Yeah.
The percentage sign, does that mean mod?
Yes, so it's the modulus division.
And so the modulus division, which part of that line is actually the printed bit? Is it the green bit, or is the green bit, is that just that's what will appear, and then the black bit, is that the bit that's the actual calculation that's going to happen?
Yeah.
And is modulus the mod, is that what's remaining, right?
Yes.
So if it's, hang on, if it's div, it's how many times that number would go in, so the answer would be 3. But if it's mod, it's whatever's left.
Yes.
And what's the percentage sign is the mod.
Yeah, so in Python,
do you not, so you wouldn't write mod?
So in Python you can't write mod, and so obviously when we're teaching Python, we stick to obviously the Python syntax for it. I don't put the mod inside the speech marks. Let's say for this reason, it was because I wanted them to get something wrong, and not necessarily understand what it means to begin with. And then they can then see and start to work it out. There'd be nothing to stop me putting mod between it, like in the speech mark section, the string section. But I just chose not to really, just because I wanted them to start to think about it on their own.
Thank you.
No problem. So yeah, so that's obviously the chance. So obviously they spend a few minutes, and obviously you're more than welcome to type it out and see if you can get it working and see what happens. And so then the next stage obviously is the investigate section. So within here, so this is where I then give them the chance to answer some questions. So these are things that I've kind of tailored into it. What do I want them to learn from it? And so looking at things like the constructs, so looking at introducing those. So I tend to introduce those right at the very beginning, before we start to do any programming, just so they're aware of what they are and what they mean. And then I want them to be able to link those in as we go through. Obviously the data types is something that obviously I did talk about before this as well. And then obviously looking at the speech marks and obviously how that ties in with the data types. And I also wanted them to focus on things like what the comma is doing, and why we use that, and describing each of those operators and what they mean. So I hadn't, before the lesson, mentioned any of the operators. Obviously most of them are okay with using the plus sign, because obviously they see that in maths. The majority of them understood the multiply sign, so the star, and what that means, and very few initially understood what the percent sign was until they actually typed in the code, and worked it out. And so the investigate really, I think, is a case to make sure that they have run that code properly, and they can then run it as many times as they want. And so they can have a look through and start to answer. I do look at see in the investigate, just getting them to think about whether they've got it right or wrong as well as the first section, just so that they can have a little bit of a, hopefully for some of them, a confidence boost that yes, they got parts of it right, or some of them might have got all of it right. And then if they really don't get it correct, then it's a case of looking at them explaining what happened if that was the case, just so they can then compare their prediction to what actually happened, and hopefully then obviously learn from that. We use a Python editor called Thonny. I don't know if many of you have heard of that or use that. I'll just go switch to that one. So bear with me.
Martin,
Yes.
is there any? It is Martin, isn't it?
Yes, it is. Yeah.
Yeah, sorry. Is there any chance that you might enable the chat bit so that instead of disturbing you, I can write questions?
I was talking about that a little while ago. At the moment, I think when you're an outsider to the organisation, it makes it difficult for me to do that. Because I think there's a setting that I'm trying to get the technician to change for me so that it can happen. I can't do it because I'm not admin for it. But in future, if you want to carry on and come along to the other sessions, what I can do is add you as a guest, which then allows you to then participate in it if you use my links. So I'm more than happy to take your email address for future sessions so that you can use the chat feature instead if you prefer it. But seriously, feel free to just ask questions. I think if you just interrupt me every so often, it's really not a problem, because I think a lot of the time
you have no idea how stupid I am. I'm literally bottom set everything. Just so you.
We all start off like that, don't we? God.
That's the whole point.
I can't believe how stupid I was when I started teaching computer science.
Yeah,
I can't believe anyone let me in the classroom.
But I think that's what it is. It's a case of everyone has to start somewhere, and that's why I've kind of put these sessions in. So if you've got a question about what some of the code I'm showing you is doing, then ask. There's probably someone else that's thinking about it, or even may not have thought about it, but actually finds what we talk about useful. The number of times I've been on a course, and so I did a computer science degree, but even still the number of times I've been on a course and someone's explained something in a slightly different way that I hadn't necessarily thought about, I think it's still useful. So like I said, by all means, feel free to interrupt, because I think it can help with other people's understanding and obviously your own as well. So don't worry about it. So yeah, so can you all see my Python editor now?
Yes.
Should be on the screen.
Sorry,
So
Martin,
this is
to interrupt. Can you just tell me what editor you're using there? I don't recognise
yes.
it.
So this is Thonny. So
And do you have that locally, or is it a web-based one?
so it's a local one that you get installed. It's built. It's basically a Python program that's that runs and then obviously just creates its own version. I've only been using it for the last year, but I found it when I went onto a course at Raspberry Pi.
And you
And
prefer it to
noticed that,
idle?
yeah, there's a couple of things. Obviously, the main thing is it's just one window instead of two windows,
Oh yeah, of
which
course,
means
yeah.
that the students tend to find it a little bit easier
Mm.
when they're learning. What I've actually found is, so my year 9 group, they did some Python in year 8, and they used idle when they're in year 8, and a lot of the year 9 students prefer to carry on using idle instead of using this.
Yeah,
But when I've been teaching this straight away to my year 8s,
yeah.
the kind of the reduction in the number of issues that I've seen has been really quite significant.
Yeah.
So
Only key stage 3.
yeah, so
Okay.
with obviously idle, I was finding time and time again that they'd write straight into the shell instead of creating a new file. And I think because the Python editor, if you like, is at the top, it makes a lot more sense to students as they're starting to learn. That's where you write the code. I also like the fact you've got the line numbers in there as well.
Yeah, I like the line numbers.
Which
That drives me nuts in idle.
yeah, which obviously that means you can refer to them, and kids can then refer to line numbers and
Okay.
that sort of thing, which
Thank
makes it
you.
a little bit easier.
Yeah,
But also the debugging tool is a lot easier to find. I don't know how many use it in idle, but the debug is built straight into it, so it's just a button, and so they can then go through line by line. So if they click the debug button, it highlights lines and they can step into it, and as they step into it, it will highlight each part of what it's doing. So looking at each of the numbers in this instance, then realise it needs to add them together. Then it's obviously saying, right, okay, I'm going to print 4 instead. And so then at that point, it's then got 4. And then it goes on to the next line.
Are you still running idle on yours? Because what we find sometimes is when we run multiple things like Visual Console and idle, we have issues with libraries.
Yeah. So I've not had any issues with any libraries or anything like this. You just install idle and then just install this over the top. They don't open idle at all with anything.
Okay, I'll try it. It sounds
good. It just opens and then kind of has Python in the background as it's going.
Thank you.
And I said that the tools that it's got, they're just a little bit easier to find, I think, and I think that the user
that looks better for key stage 3, definitely.
So the only slight issue that we've had with it is that by default the options, I think it's this one, so it uses the default scheme that isn't the Python editor, and so my issue has been that I prefer the Python standard ones because that's what I've always kind of learned. And so all of my resources are using that, and so the students then just have to say change it.
Yeah, and you can make it bigger for VI students.
Yeah, so obviously the font sizes are in there, and they can change the font size, and they can change all sorts of things if they need to. They do have to change the settings every time they log on, though, which is a little bit of a pain, but they soon get used to it, and then most of them towards the end, once they've got used to the fact there's different colours, don't even worry about changing it too much, so they don't worry too much about it. But yeah, so I quite like using it. Feel free to have a look at it and see what you think as well. But obviously that's where the investigate side can really come into it. You can get them to use that debugging tool to go through it and think about line by line. And obviously with this one, so if I go to the question about us looking at about what happens when the speech marks are used around the calculation. So on line 2, obviously we can really see that and see what Python is actually doing with that, and how that was different to the previous line where it was looking at each individual item beforehand. This time it only looks at the whole group of characters and then prints the whole group instead. And so obviously you can get that kind of understanding in there as they go through. The comma side of things, again, you can say, well, actually have a look at what's happening. So it takes the first part and then it realises, right, that's the first bit that's going to print. But then there's a second part of it now, and then it goes through and does the calculation for the next part. And then obviously it shows them the result at the end of it once it's done the calculation, and then prints everything all in one go.
I didn't get any first question, but I got two.
See what's going on. So yeah, so that's the thing. I'm just going to shift.
Are you talking to me?
Yeah.
What?
It's saying I got this question completely wrong with this. I got 2 right out of 4, but it's not. It's saying I've got 0.
So obviously that's the investigate bit.
At least it's tracking.
And so the next bit is then where we get to modify it slightly. So in this case, I just asked them to modify the first line so it displays the calculation before it is worked out, and that on the second line it then does the answer as well. So basically getting them to do what I did for line 3 here and for line 1 and 2, just to make it a little bit clearer. And obviously that's where hopefully starting to come into thinking, well, actually I'm just copy and paste it, or I can just copy exactly what I've done there and just change bits and pieces, just so that it then meets that that definition of what I've asked them to do. And then they've got the make task, and so obviously that's very similar, just getting them to do 2 mathematical calculations. Again, they should hopefully realise how to just use what they have done beforehand to make it a little bit easier. One thing I did forget to talk about is with this kind of model, we have kind of developed a high level, high, mid and low level version of each of them. There's not a huge deal of difference between them, but I try and build in a little bit of scaffolding for the lower abilities as they go through. So for the mid version, I don't change anything at all apart from in the make task, where I give them some instructions in English that will that they can then use and try and convert that into Python as they go through. So just like getting them to say, right, display this and then display that, or use an input or whatever it might be. Excuse the dog, sorry about that. When it comes to the really low ability students though, I've made a fairly significant change to it. They only do the first 4 parts initially, and so within a lesson they'll do 3 or 4 copies of just up to modify, and the modify will have some comments in there that will help them to understand what they need to change. But then the make tasks I do get them to do at the very end of the lesson, so there will then be 3 or 4 make tasks at the end, and they just work through all of the make tasks one by one. I've tried a number of different ways of getting them to do it as they go through, but what it has done in terms of doing it this way is just help to focus on kind of the bits they can really do successfully, because I was finding a lot of the low ability after doing one Python activity was struggling with the make task still. So what I'd get them to do, let's say, is if they just go up to modify, most of them were fine doing modify quite easily, and so they can do 3 or 4 of those, and then once they've done 3 or 4 of those, they tend to find the make tasks a little bit easier at the end, and so they can then quite quickly go through doing 4 of the make tasks if that's what they need to. And what we also do is a little bit of a kind of flexible learning with it. So each lesson or section will have 3 or 4 activities on there based on one particular tool that they're going to use. or technique, I should say. And tell you what, this bit is very weird compared to how I would do it in the lessons, where I can go around and have a look at how people are getting on and judging when they might need to stop and if they need any help and things like that. While you're doing that, I've just got to go grab something from the door. So I'll be back in a second. Sorry about that. Dog was going mental. So have you managed to get that running now? Was anyone correct with what they thought might happen?
Yep, I was.
Okay. So in the end, what did happen?
Well, the last one is a syntax error because it doesn't understand +4.
Yep.
And then the other two, they just print the same thing. Whatever's inside the bracket is recognized as as text, so you can't do any calculations to it. So it's literally just taking whatever's inside the quotation marks and printing it times however many times it said, because whatever's not in the bracket is recognized as an integer, so it's doing it that amount of times.
Yeah. And so this is a really, I think, useful bit within the lesson of students starting to think about kind of the different data types and how they can behave differently to how they might expect. You'll probably find a lot of students initially think, especially in the first one, will be 40 as the answer, and that will be what will be displayed. And then they might not have any idea about what number 2 might do. And then obviously number 3, they might think that it just does 30 plus 4, so to get 34. And so you can really start to have a bit of a discussion, and then with the investigate part, you can see I've kind of tried to drill down into this one, kind of exactly what's going on, and get them to think about it. So the different data types, I get them to identify what those data types are, get to think about how line 1 is actually working, and so this is where again they can use the debug tool to step through and step into each of the different tasks, and then obviously describe the error that has been found. So see the syntax error that was found in there, why it was causing it, and so that I can then start to talk about the fact that the string cannot be added to an integer directly. There has to be some kind of manipulation in there to get that to work properly. And then obviously the second, or the kind of final part of it, is get them to change it, and then see what happens once they've done that. So a little bit of a crossover between the investigate and the modify, if you like, but I want them to explain it as well, not just have a go at doing it, just so I can see that they understand it within that part. And obviously in there I've started to introduce the the string function and the integer function, so we can start to talk about casting from one data type to another data type, so they can then be used together. So if we cast the integer into a string, then we can then have 3 or 30 and then 4 displayed next to each other. If we have convert or cast the string into the integer, then obviously we get 34 as the answer.
So for, hang on, bullet point 1, 2, 3, 4, 5. So
I should have numbered them, shouldn't I?
So bullet point 5,
yeah,
when it will print out 34, but it's
yes.
not actually print out 34. It's just printed. It should print out 304. Was that right?
So as it was initially, it would print 304. Or,
yeah, and then if you then line 6 would then print out 34, 34.
Yeah. Yes. So the int function casts the string 30 into an integer, and so then it's just doing addition. Later on, when I'm teaching, obviously we talk about things like concatenation, which is what's happening in the 5th bullet point, so the 30 and then the 4 next to it, and how the plus can be used for either joining strings together, which is what's happening on that line, or on the final bullet point, use it for addition, so you can add 2 numbers together.
That is a really, really good task. I totally see how that works in the classroom.
Thanks.
Just those last 2 bullet points, really, really good.
Yeah, and I think that's what the ideal part with this investigate section. This is, I would probably say, the most important part of it for getting them to understand how the code actually works. If they've got that section and they've answered those questions well, they then generally find the make and the modify tasks very easy. And so when I'm looking through their work, a lot of the time I don't really bother looking too closely at the code. I'll tend to focus on them answering the investigate questions, and if they're getting the investigate questions correct, I'll glance through the code